see your picture popping up on my screen.
Yep,
Okay, I can hear you, so why don't you go ahead?
okay. Um, Question was, why did I include the other, look at the
Yes.
other
Mm-hmm.
factors, the covariates? Yeah, okay. Again, as the question came up on education, to rule out other possible explanations. One could be that education could better explain the diabetes status rather than acculturation modes. Also, differences in BMI, body mass index, fasting insulin, and other factors known to be associated with diabetes could better explain because they're different across these groups.
Okay.
Um, Unfortunately, Diabetes Care wouldn't take our full paper, so we had to submit a brief report. So we eliminated a lot of data and a lot of other things. But actually, education was not statistically different across the four modes. Neither was BMI. So I believe the BMI was averaging about 30, 31 across all modes. So there was no difference in body mass index and no difference in
Mm-hmm.
education. Um, as far as acculturation is concerned, there were differences, of course, as you expect with age, BMI, triglycerides, and fasting insulin, and diabetes, as one would expect. Uh, we did we didn't we didn't adjust for these factors because none of them were found to be confounders. And Fran, correct me if I'm wrong, but a confounder is associated both with the outcome and the independent
Mm-hmm.
variable of interest. And because there were no overlapping significant correlates, we did not include it. However, I did include it just for my own, out of my own curiosity, and put in these, and it didn't really change too much the outcomes. The percentages slightly dropped a bit, 27 to maybe 26 or something, and so forth. But the one of the reviewers had a critique about adding these factors in. They're not really confounders. Um,
That was great. So if I could just summarize or comment, let's talk about education. I presume that state of knowledge is that people who are less educated are at higher risk of developing diabetes. Is that the direction of an association between education and risk of developing diabetes, if it exists? That lower education is at higher risk than higher education, or does it work the other way? Does anyone know? Okay.
it's lower
So, for
education, higher
example,
risk for
what we would
disease.
be concerned about looking at this figure is if we look at the 86 people who are in the traditional group, and if Chiave had found that most of them reported to have lower educational levels compared to the 300 or so people in the integrated group, where most of them would report, for example, if they had reported higher educational levels, then we could maybe be concerned that the higher prevalence we see in one group is not due to the definition of the group, meaning traditional acculturation or integrated acculturation, but the type of people in the two groups are different with respect to another factor, education. Education is the reason for the higher prevalence because education might be low education might be a high risk factor for developing diabetes. Now, before we leave that example of education, Gavin mentioned that there was no significant difference in the educational levels in these two groups, and that's the reason that uh, you could probably make the argument. And just again, confounding is something we'll talk about in more detail in a couple of weeks. But yes,
Hey, Fran, I need to correct something, Fran. Yes to Amir, yes to Aaron. Oh, Fran, I need to correct that because I'm getting confused
that's
between two
okay.
studies I'm currently working on in the educational. Actually, education was significantly associated with this group, but it was not
Okay. The,
associated with
the,
diabetes
uh, the
status.
last point I wanted to make before I left education is if you compared, say again, the traditional group to the assimilated group, now we have a problem here. Remember, there are only 8 people in the assimilated group. And it could be that the assimilated group were very different from the traditional group with respect to any characteristic like education. But that difference wouldn't achieve statistical significance just because we don't have enough power in a study with only 8 people in one group. So we'll talk about power, we'll talk about statistical significance in a month or so, when we talk about the statistics portion of these seminars. And then we'll talk again about how confounding is related to statistical significance. So those were just, and I thank Kiabe for his help on this first example of a cross-sectional study. What I'm going to do is just say a few last words about cross-sectional studies. And first, just to summarize them, just so we're all on the same page before we leave it, is when we think of these various study designs, we should think about the advantages and the disadvantages of one design over another. Because then when we do a study, which I'm going to ask you to think about for the next couple of weeks, you're going to choose which design you think is best for that particular study. So thinking of Kiave's study, what is the advantage of doing a cross-sectional study? I mentioned it's a snapshot. It's like one-stop shopping. You go to your grocery store once a week and you buy all your vegetables for the meals for the entire week. That means you have much more time to do other things for the rest of the week. You don't have to run to the store every evening on your way home. So cross-sectional studies are very efficient in terms of time, very efficient in terms of cost. And as a result, they're going to be very favorable in terms of being less expensive in time and energy compared to other designs we'll talk about later today and next week. Disadvantages. By far, the biggest disadvantage is that cross-sectional studies give you prevalence data. And remember, prevalence data is a function of both incidence and duration. So when you find an association in a cross-sectional study, one group has higher prevalence than another, you don't know whether that first group has higher incidence of developing disease, or that first group has better duration of disease, or in some studies, you're not sure whether what came first. I mentioned chicken and eggs, or horses and carts, whether the disease is causing the exposure status or the exposure status is causing the disease. So those are the big limitations of cross-sectional studies, but don't forget about the advantages. Don't forget about the fact that they are very easy and quick to do. Because I'd like to leave you with just a plug, is that there's lots of data available for anyone to use. That's online through the Centers for Disease Control. And I give you the website here for the CDC. You can go to their website and look at it. And they'll actually provide assistance for helping to use those data if you want, in terms of they'll describe it for you, and they'll actually provide, in some instances, some statistical and programming support. But in my experience, what I've done is I've worked with colleagues that will actually download their data and analyze all the data themselves. So this is an opportunity to use existing survey data sets that's available to describe our nation surveys or state surveys. You could probably limit it to people living in Alaska or living in Hawaii if you have that data. And it allows you to use those data to answer some very interesting questions. And people make careers, research careers, out of just using these secondary data sets. So for example, I just mentioned two of them here. There's something called the National Health and Interview Survey, the NHIS. This is a yearly health survey of the United States civilian, non-institutionalized population. In other words, they might knock on your door someday and ask you a bunch of questions, but they won't knock on your door if you're a member of the armed forces living on an army base, or in your case in Hawaii on a naval base, or they might not knock on your door if you're living in a nursing home. So it's a non-institutionalized population, and they definitely won't knock on your door if you've been arrested for a crime and are in prison. But hopefully none of you will be in that situation. What they do is they try to take a representative sample of the United States. They divide the country into sampling units, primary sampling units, which are usually counties or lots of states or metropolitan large cities. Then in each of these cities, they randomly try to select households. They try to select about 40,000 each year. And they record in their survey demographic information, whether a male, a female, a old or young. They probably collect some risk factor information like smoking status, drinking status. They record whether you have been diagnosed with both acute and chronic illnesses and how much you've utilized doctors' offices, hospitals. So this data is available to answer a lot of health services research questions. Another large data set that's available is something